Welcome back, students. Again, as a continuation of a previous session, here I will be teaching you how few more other problems that are associated with the electricity could be solved. So, the first question goes like, the resistance of the wire is 0.01 centimeter radius is 10 ohms. If the resistivity of the material of the wire is 5 into 10 power minus 8 ohm meter, find the length of the wire. Again, here in this question they are asking us to find the length of the wire given that the radius and the resistance of that wire is given. So, the capital R is equal to rho into L by A it is. Rho into L by A it is. So, L is equal to R into A by rho. R into A by rho. So, L is equal to, the resistance of the wire is 10 ohms into the area. Area is nothing but 3.14 into, see the radius is already given, but in terms of centimeters. So, please express it in meters, where 0.1 into 10 power minus 2 meters divided by the resistivity of it is 50 into 10 power minus 8. So, now all we have to do is we have to calculate the whole equation to get the answer. So, it is a simple multiplication and division. So, I will not be doing it on the board, I will just leave it to you. So, I will just directly give you the answer that it is 62.8 centimeters, otherwise it is 0.628 meters. So, this is the length of the wire. So, see again it is a simple question where you have to just pull out the data from the question and you have to substitute them in their respective places in the equation. So, now the next question goes like, draw a circuit diagram for a circuit consisting of a battery of 5 cells of 2 volt each and 5 ohm resistor, 10 ohm resistor and 15 ohm resistor and an ammeter and a plug key connected in series. Also connect a voltmeter to record the potential difference across the 15 ohms resistor and calculate the electric current that passes through the circuit and the potential difference across 5 ohm resistor when the key is closed. So, it is again a very simple circuit. See, we have 5 cells attached to it. So, first let me take 1, 2 and 3 resistors. 1, 2 and 3 resistors. I have 5 cells connected to it. 1, 2, 3, 4, 5, and then I am going to connect an ammeter. Ammeter is used to measure the current through it. So, this is 5 ohms, this is 10 ohms and this is 15 ohms resistors. So, each and every cell is going to have a 2 volt each. So, now the very first thing that we are supposed to calculate here is the electric current that is passing through the circuit. So, the electric current is the one that is going to be measured by the ammeter over here. So, what is the formula that we use to measure the current? I is equal to V by R. But here we do not have a single resistance, but we have 3 resistors connected in series. So, the equivalent resistance in this case is R1 plus R2 plus R3, which is equal to 15 plus 10, 25 plus 5 is 30 ohms. So, this is the equivalent resistance. So, by using this I can directly find the current. Current is the one which is being measured by the ammeter directly. So, it is 2 volt each. So, totally we have 5 cells connected in series. So, each and every cell's EMF will get added up. So, 2 into 5 is 10 divided by the equivalent resistance is going to be 30. So, the current over here is 1 by 3 ampere. So, on each and every resistor in the circuit, a current of 1 by 3 amperes will flow in. Now, in the second part of the question, they are asking us to find the potential difference across a 5 ohm resistor. Okay. So, what is the potential difference across the 5 ohm resistor? You see, this is the 5 ohm resistor. Across it, I will put a voltmeter. So, this voltmeter across the 5 ohm resistor will tell me how much amount of potential drop that I am going to face. See, it is again very easy, because since 3 resistors are in series, the potential drop on each and every resistor will be different. So, V1 is equal to I into R1. V1 is equal to I into R1. So, what is the total potential here? Sorry, this is V1 is the potential drop. Okay, the total potential here is 10, but we will not be substituting 10 here. Instead, I will just put the current that I have calculated, which is 1 by 3 into the resistance here, which is 5, will give me the potential drop on the resistor 5. So, V is equal to 5 by 3, which is equal to 1.6. 1.6, because if I put 1, you will have 3 balances 2, 6 is 18, and you will again have balance 2, so it is 1.66 volt. So, this will be the potential drop across that 5 ohm resistor. See, it is again a very easy question, but here you have to clearly understand that what they are looking for and what you are supposed to calculate. See, first always find the equivalent resistance whenever a circuit is given. Then remember that current through any components that are connected in series will be same. Likewise, the potential drop on any component that is connected in series will be different. So, keeping this in the mind, you can directly calculate everything. Yes. Now, this brings us to the next question. Here, a fuse wire melts at 5 amperes. A fuse wire melts at 5 amperes. If it is desired that the fuse wire of the same material melts at 10 amperes, then whether the new fuse wire should be smaller or larger in radius than the earlier one. So, here there are 2 different currents that are going to flow in. First, when 5 amperes current flow in, a fuse wire melts. So, they are asking you to find what should have been done to the second fuse wire where it melts when 10 amperes of current flows in. So, how should your second wire be? Whether the radius of the wire should have been increased or it should have been decreased. That is the question that is asked here. So, here actually we are trying to calculate the heat energy that got dissipated through the material, and the heat is calculated as H is equal to I square RT. So, this is a standard equation that we will always use to calculate the amount of heat energy that gets dissipated. So, looking into the problem, we have current, 2 different currents flowing into the same material. So, my first equation H is equal to, H is equal to phi squared into R. Then in the second equation H prime is equal to 10 squared into R prime. See, the heat changes at the same time, the resistance should also change. So, I assume that the heat is going to be same in both the cases, and I will compare the equation as 10 squared into R prime is equal to 5 squared into R. So, R prime is equal to 25 by 100 times R, it is 1 by 4. So, which means that my resistance is actually going to get decreased. My resistance is going to get decreased. Okay, so for the resistance to decrease, let's see how the equation is going to respond. This is the equation for the resistance, and I realize that my resistance is going to decrease. If my resistance is going to decrease, I am very sure that my area of the material is going to increase. So if the area of the material increases, I am very sure that the diameter or the radius should be greater. So definitely in the second case, we would have used a thicker wire. Okay, that is what I could conclude from the data that is given to me. Yes, now this is how the problem could be done. It is not that all the time you have to be provided with the data with which you can directly plug them into the equation to do the calculation. In few other cases, they might also ask you for some logical questions which you have to think deep to answer, something like this. So now we move to the next one. See, here you have two lamps, one rated at 100 watt and the other one rated at 60 watt. Both are connected across the same voltage, okay, but they are connected in parallel to the electrical main supply. Okay, find the current drawn by two bulbs from the line. See, they are connected in parallel. Just consider them to be two resistors that are connected across a same battery. Just consider them like that. Instead of giving the resistance of the material, they have given you the power. Okay, what means power? So what I do is, I accordingly make some changes. I know that when two components are connected in parallel, then the current through those components will be different. So the total current is nothing but sum of the individual currents. Sum of the individual currents. So I1 is the current through the first component. So how to calculate I1, whereas the watt is given here? You see, power P is equal to I square R. This is one formula. Otherwise, I into V. This is another formula. So I am sure that since the resistance of the material is not given to us in the question, it's better to go with the second formula. So now the power that is given in the first case is 100, which is equal to I1 into 220, and in the second case it is 60, I2 is equal to 220. So now we know the current for both the cases, and I will just take those currents and I will add them up. The total current I is nothing but sum of the individual currents, which is 100 by 220 plus 60 by 220. So I is equal to 160 by 220 it is. Zeros will go down, I is equal to. So how could we cancel this out? It is 8 by 11. 8 by 11 is nothing but 0.72 amperes. So this is the total amount of current that we are looking for. See, this is how easily it is done. All I have done is, first I realized that there are two electrical components that are connected in parallel to it, and then I realized that the current that are going to go through two individual components are different, and I separately find their currents and then I will put them in. Okay, so these are the few basic methods that you have to follow to solve these questions. Okay, now we move to the next question. An electric bulb is connected to a 220 volt generator. If the current drawn from the bulb is 0.5 amperes, find the power. So first let me solve it. A. They are asking you to find the power, whereas the voltage and currents are given. So, power P is equal to V into I. Power P is equal to V into I. So, P is equal to, what is the voltage here? It is 220 volt and the current I is 0.5 and the current I is 0.5. So, P is equal to, I will take this 0 and I just put it over there. It becomes 22 into 5. So, P is equal to 110 watt. So, this is the amount of power that went out. See, it is again a straightforward question. All that you have with you is the current and the voltage. So, now you take those current and you just put them inside to calculate the power, because the formula for the power is straightforward, it is V into I. So, put them in and you will get the answer. Next, the B subdivision. An electric refrigerator rated 400 watt operates for 8 hours a day. Calculate the energy per day in kilowatt hour. See, using this method, we can even calculate the electricity bill consumption in every domestic home. So, kilowatt hour is the unit of energy, and the electric appliance is 400 watt power. So, look what I am going to do, 400 watt into 8 hours. Okay. So, the equipment with 400 watt is operated for 8 hours a day. Like this, I will say that it is being operated for 30 days. Like this, it is being operated for 30 days. Then you can calculate it for a month. But they just want us to calculate for a day. So, 400 into 8 is 3200. 3200 watt. Okay, watt hour. So, we have calculated it in watt hour. They are asking us to calculate in kilowatt hour. So, the energy E is nothing but 3.2 kilowatt hour. Kilowatt hour. So, this is the amount of energy that is being consumed. Okay. Now, C. State the difference between the kilowatt and kilowatt hour. So, first, kilowatt. Kilowatt is a unit that represents power. It represents power, whereas kilowatt hour represents energy. Kilowatt hour represents energy. Okay, see, this is how easy it is. So, here we haven't done much with anything. All we have just done is we took the data from the question and I figured out the formula with which we could calculate it, and I have plugged in the data and we did some simple calculation to get to the answer. So, this is how almost all the questions are solved, but few questions will be pretty tricky, which you have to be very careful and you have to be conceptually strong to solve them. So, with this note, we come to the end of this session. We will again meet in the next session with a different set of questions or different set of concepts. Thank you.